Hello everyone, welcome to the video. In today's lecture in CGV subject, we are starting with the basic of midpoint circle algorithm. So first of all, we started with a simple basic circle definition. So what is a circle? If I take one point, one fixed point, then draw a plot all the points along from the one fixed points, which is taken a equal distance from this particular point. So a circle is a set of all the points that lie at an equal distance from a fixed point. It's called as a center or a circle. In the definition of a circle, center means fixed point, and a equal distance is a b as we noted as a radius. So circle is a symmetric figure. You have a question. What do you mean by symmetric figure? In a circle, we have two type of symmetrics. One is a four-way symmetrics and second is eight-way symmetrics. So first of all, we start with the four-way symmetrics. In a four-way symmetrics, we have a horizontal and a vertical line. So the vertical line is denoted as a x-axis and horizontal line is denoted as a y-axis. So there are four parts. 1, 2. Here is a one part, second part, third part, and another one is fourth part. So if we have a given one coordinate or plated, so that coordinate with the particular axis through the reflection of another axis, we have a second coordinate. If we have reflected through both of coordinate, then we have a circle, or we can draw a complete circle. Here is a particle region or a coordinate. We take name as a coordinate 1, coordinate 2, coordinate 3, coordinate 4. So it is a four-way symmetrics. Now we go for a eight-way symmetrics. So four-way symmetrics was a form for four coordinate: coordinate 1, coordinate 2, coordinate 3 and coordinate 4. Now we go for eight-way symmetrics. So eight-way symmetrics will be formed for 8 octane: octane 1, octane 2, octane 3, octane 4, octane 5, octane 6, octane 7 and octane 8. So in this we use the midpoint algorithm to calculate all the parameters points of the circle and the first octane and print them along with their mirroring points. If we give an octane 1, we mark as x, y. So we corresponding from x, y point or a plot with 7 more octane points or more plotting points by using the transformation of these points. So this is all the circle algorithm. For any given pixel x, y, the next pixel will be plotted is either x, y or either x, y plus 1 or x minus 1, comma y plus 1. This can be decided by following two steps. Here is the two step. One is find the midpoint. Find the midpoint P of two possible pixels. And second one is if P lies inside the or on the circle perimeter, we plotted the pixel x, comma y plus 1. Otherwise, if it's outside of the circle, we plot the pixels x minus 1 or y plus 1. The boundary condition plus 1. The boundary condition is whether the midpoint lies inside the or outside the circle can be decided by the circle formula. Now we go for program. So first of all we open the Turbo C. Go for file menu, open the new blank file. So first we include essential file. It is has include iostream.h. Second header file is has include studio.h. It is insert input output. Third is include conio.h. And in this program or in this practical we run the graphics. So we include the header file of graphics. So include graphics.h. Okay, is it clear? For circle generation we implement the midpoint algorithm. So we implement the void main function. So void main bracket. In this bracket we use integer functions. So integer xc or yc and yc. xc and yc are a central coordinate of the circle that will be entered from the user. Then x and y. X and y are initialization value. Then r. R is the radius of the circle. Then decision parameter. We have used d or p. I taken as the decision parameter as a d. Then Then the graphic drivers GD is equal to detect, comma, the graph mode GM. Then count, enter the radius, and L, C in R. Okay. Then we initialization x and y values. So first x is equal to 0. Then y is equal to r. Y is equal to the radius of the circle. Then decision parameter d is equal to 1 minus r. Then init graph function is a graphic initialization graph. So init graph address of the graph driver, address of the graph driver, address of the graph mode, and the path of C programming or Turbo C. So C Turbo C3 BGI. Now for enter the coordinate value from the user, count, enter the coordinate of the circle and L, C in XC, XC and YC. Then do loop, do put pixel for the circle generation. So put pixel XC plus X, comma YC plus Y, comma 4. 4 is a fourth coordinate. Again put pixel, again XC plus X, comma YC minus Y, comma 4. Put pixel, XC minus X, comma YC plus Y, comma 4. Put pixel, XC minus X, YC minus Y, comma 4. Put pixel, xc minus x plus y comma yc plus x comma 4. Put pixel xc plus y comma yc minus x comma 4. Put pixel xc minus y comma yc plus x comma 4. Put pixel xc minus y comma yc minus x comma 4. Then if condition, if d is less than to 0, then what will happen? If d is less than 0, x is equal to x plus 1, y is equal to y, d initialization distance parameter d is d plus 2 into x plus 2. Maybe d is not less than to the 0, or then the else part, else x is equal to x minus 1, x plus 1, sorry, y is equal to y minus 1, d is equal to d plus 2 into x minus y plus 1. Complete the while loop. While loop x less than y. Get CS for the completion of the program. Get CH and close graph for completion of the graph and run. Okay, integer, sorry, typing mistake of declaration program. Enter the radius. Radius is 100. Enter the coordinate. 200 and 200. So here is the output of the program.